Good morning, everyone. Thank you so much for joining us today. I am honored to be hosting this panel session with Dr. Rob Calderbank and Dr. Anton Monk. My initials are DR, but I am sadly not a PhD. That's the only joke I'll do this morning. My apologies. It's great to be with you. We are sad to be missing Martin Weiss from the Future G office due to the shutdown. He is unable to join us, but certainly always with us in spirit. So, gentlemen, thank you so much for taking the time. Anton, I know you're on the West Coast, so please feel free to drink lots of coffee during our session. I know, there you go. I know this will be incredibly informative as we take a look back at 5G and how we can best inform our take in moving forward on 6G. So first, I would love to get this started just by offering you both a couple of minutes to introduce yourselves, your background, and then we can get started with some of our questions for today. So, Dr. Calderbank, would you like to go first?
Sure. So I'm Robert Calderbank. I started out my technical life at Bell Labs working on voice band modems, which were considered high speed at the time, 28 kilobits per second and below. I ended up running research for AT&T. Since 2003, I've been an academic, first at Princeton, now at Duke.
Fantastic.
And in terms of wireless, I have some of the core patents on spatial diversity.
Fantastic. Very impressive. Anton, please.
Yeah, can't tell who's on the call, of course, but pleased to be here. I'm currently I think I have 3 panels and talks in 3 days, so I'm floating around. I'm currently at LAX Airport Marriott, very exciting, at Milcom, which unfortunately doesn't have as many people as it usually does because of the shutdown, but still very interesting talks. My background is semiconductor systems and the cable space. Started a company that developed home networking technology called MoCA, which some people may have heard of, not in the wireless space, but it's deployed in tens or, I don't know, 100 million homes around the US for home networking of video. And then I worked in the satellite world and at Viasat on direct-to-device connectivity, and then in wireless on 5G with Cohere. And I'm back at Cohere where I was about 10 years ago, and worked within 3GPP and trying to convince people to adopt our waveform OTFS. And of course, the company has now expanded beyond just OTFS, but we still look at it for ISAC applications and for 6G and beyond.
Fantastic, and look forward to digging into that a little bit further in our session today. What I want to start out with is just kind of a look back, or a look in place with 5G, and as we look to 6G. There's been a lot of questions about 5G and its success, and how we can take lessons learned as we move to 6G. So, Dr. Calderbank, how is 6G fundamentally going to differ from 5G in its approach to connectivity, particularly with the integration of ISAC in programmable networks?
Yeah. What I would say is that one of the things I think we learned from 5G is that services don't just happen. New applications don't just happen. And what I'm hoping is that in 6G we can learn from that. I mean, in some sense, people pay for data communication. So that's the core service that carries the load. And when we think about new technologies like ISAC or machine learning, they should make a fundamental difference to the core market, data communication. And I can talk about different ways that that can happen. But I think that new ideas that add value to data communication and also have spillover value into new services are more likely to end up in widespread adoption.
So with 5G, the question was always improved networking, but not necessarily the consumer experience. So as we move into 6G, who's going to benefit? Who's getting excited about this? Is it the consumer's turn? Do you see the applications coming online, or will it just, I always like to say sometimes just being better, faster, more reliable is an improvement of the consumer. But who's really getting excited about the 6G?
So I think that at the end of the day, 6G happens when mobile network operators decide to spend money.
Mhm.
And so I think that the first order of business is to explain to them how things like sensing functionality make a difference to their core business. So, for example, by sensing the effective channel, can you buy time for signal processing? Can you buy time for MIMO scheduling? Can you improve your spectral efficiency?
Mhm.
These are things that I know carriers care about. They may be things that enable new applications down the road, but starting with the value to the carrier is a really good idea.
Absolutely.
I think the days of consumers seeing some fundamental shift as a direct correlation, a direct correlation with the standard may be over. I mean, because with faster, better, not necessarily cheaper, more reliable, what the industry has enabled is the upstream players, the app developers and the solution developers. So I don't, and that's probably one of the missed expectations or misunderstood expectations of 5G from a consumer perspective. It was never really designed to offer something significantly better to consumer, even though there was a lot of hype about a gigabit per second related to millimeter wave. That's unfortunate because I think it led to the perception of failures in 5G. That and other exciting verticals like VR and industrial IoT and massive machine type communications. We were all talking about these new capabilities, but the consumer never really would have seen them directly, and they haven't evolved at the speed or even at all that operators expected to generate new revenue. So
Mhm.
that's, I think, one of the lessons we have. And one of the, you asked what's fundamentally different. I think there are new paradigms. There has to be new paradigms as we go from G to G. Otherwise, why would there be a new G? And that's becoming more and more difficult to justify because, what are these step functions? But sensing waveforms, which I think hopefully we'll get into, and integrated sensing is one of them. AI is another one, but AI is sort of generic. AI means different things to different people. And we could perhaps talk about that. But these new paradigms like sensing bring new metrics, and new metrics, new capabilities demand new functionality in the spec. And so, again, it's not clear that it'll be as valuable to consumers as it is to businesses. And, I think we'll talk hopefully also about some of the use cases that will be enabled.
Yeah, absolutely. I look forward to discussing use cases. I know that's always kind of helps people make it more tangible in their minds. So just staying with the 5G thread for a minute longer, Anton, like what do you see as lessons learned as we move into the design and test and deploy of 6G? Will it be incremental? Will it be transformational? I mean, it seems like you were kind of getting to this point talking about the integrated sensing.
Yeah, I think even with new features like integrated sensing, the fear, at least not just of us, but of others, is that the pace of change or the pace of adoption or the way decisions are made in 3GPP could lead to fairly minimal changes at the waveform layer, um, much like happened in 5G. I mean, again, there weren't a huge number of waveform changes in 5G, many more changes up the stack, and in terms of improving efficiencies. And there were things like lower latency and so on, but the hoped for applications and use cases like remote robotic surgery, you can safely say didn't really happen. So I think
Yes, Who,
what
who wants a scalpel run by a robot?
I think, yeah, relying on wireless, yeah, perhaps. But I think
Self-driving car? Yes.
what's different is, there is now a focus on national security and um, and U.S. national leadership interest. So those are things that could change how the spec is developed. In the past, U.S. defense, for example, didn't really have a lot of influence. They haven't traditionally, or NATO, for example. But I was in a talk yesterday, and by a leader of one of the NATO groups, and they've incorporated a lot of the big infrastructure and semiconductor players in the Western world, and they do hope to influence 6G and 3GPP. So, U.S. national or national interests can drive changes that have a different metric for success than pure profit, pure MNO profit, even though they're the ones deploying the network. So that has to be there.
Great. Well, we do have a question in the chat. You can tell I put my glasses on so I can read it. So maybe I will read this, and then Anton, Rob, I'll give you both the opportunity to respond. So as much as operators want to shift to a continuous update model, they still tend to ask for less frequent releases today for integration reasons. What do they think is an achievable rate of releases? A few a week, a few a month, et cetera, et cetera?
I'd say probably a few years. I mean, releases in terms of the spec is every few years is more reasonable. This is a bigger question that has come up in many conferences and other venues, and that is, how does the wireless industry move to a pace of continuous innovation? And a prime example is IETF and the release of internet standards and the ability of companies to develop around existing standards. And if successful and market proven, then these can be adopted into internet protocols. We don't have that. And one of the reasons we don't have that is in the wireless world is we don't have open interfaces. And I'm not sure that's going to be adopted anytime soon. I'm not talking about O-RAN, but that's a good example. I'm talking about requirements, abstraction layers within the 3GPP spec. Those would be, in my view, the right way to go to enable innovation from startups, from big companies, from academics. We're running into this problem now where it's so difficult to get changes in 3GPP that, what does it mean to have these G releases every 10 years? And how do we move to something that enables more continuous innovation and allows sort of continuous leadership as well? It's not just about the technology. That's my view.
Yeah, I mean, I think that when that open interfaces are really important. I mean, you can ask the question, who's going to make services? From my time at AT&T, I don't think network operators are in the business of making new services and supporting them. They're better at in a sense, wholesaling connectivity. Infrastructure manufacturers, they're not really set up to do services too. So it's worth thinking structurally about how services happen and how people that write software to create services might gain access to telecommunications stack.
It's fantastic. Great. Thank you. And thank you for the person to ask the question. Please feel free to those in the audience to send additional questions, and we will ask them during our session. Great. So let's focus on some of the benefits of 6G. And then, Anton, to your point, let's get into some of the use cases, because that's I think where people really get their heads wrapped around it. So situational awareness is often cited as the cornerstone of 6G. How do you see ISAC shifting the value proposition for wireless networks? And then let's talk about some of the use cases for ISAC. I know defense is often cited as an obvious use case, network management, but let's dig into ISAC and what this means for networking.
Okay.
So, I mean, so just throw out an idea. I mean, suppose you could use data communication to generate coarse situational awareness for free, right? That would be, and of course, if in this coarse situational awareness you see something, then you can deploy more complicated sensing. I think that this coexistence of communication and sensing is important because having a conversation with network operators where they're going to do sensing and they're going to do communications and they're going to partition their radio resources between the two and optimize those things separately, I don't think that's a good conversation. So I think that coexistence of sensing and communication in the same frame is a really good idea.
Maybe I'll mention some of the use cases. I mean, first of all, you said talking about situational awareness. This is a topic or a use case that's not new at all to our friends in the defense community. They talk about situational awareness all the time. There, it's generally more specifically about what assets are in the field, where are the good guys, where are the bad guys, where can I aim, what do I need to protect? And real-time situational awareness is the holy grail, knowing where everyone is at all times. So bringing that into 3GPP and 6G, these are really fundamentally new capabilities. And like I said before, the market has to be there for MNOs if they're going to deploy any new infrastructure or even software. But national security and safety interests, which encompass some of the use cases, are measured differently from profit margins. And so I think they can drive, realistically, it's probably one of the only ways that step functions and capabilities can be driven into the standards, because it's getting very challenging to make significant changes in the standard. But you asked about some of the use cases. I think there's a lot of them outside of defense, and it's really the same technology. Smart cities is one, environmental monitoring. Really, you're trying to detect drones, people, vehicles, and even fixed entities. So parking spaces, disaster recovery, search and rescue, these are related to public safety, but also in the autonomous driving world. So of course, autonomous vehicles have radar already in them. And at least when I had spoken to one of the large car manufacturers, they weren't looking to make changes to their radar systems. They're optimized for radar. But real-time awareness of surroundings, that's something that we talked about even in 5G, mostly through network connectivity. But now having infrastructure in cars, giving them the ability to see things around corners and having situational awareness for safety, for consumer safety, that's another valuable use case, I think. People talk about healthcare related things. I don't know how realistic it is, but heart rate and breathing, these are things we've spoken about with our waveform for years. You could potentially do that, privacy concerns aside. And then, of course, there's the old use cases of industrial automation and smart factories and so on. Digital twins is another interesting one that we think is very exciting. It doesn't specifically relate to target sensing. It can also just be about understanding the propagation environment and understanding how to monetize digital twins of the environment in terms of optimizing the network. That's another area that people have been speaking about for quite some time. And of course, there's many more. The real thing is we're probably going to have to build this thing and then see who's willing to pay for what. And hopefully we don't have a repeat of 5G and the market expands fast enough to justify the capital expenses.
Yeah.
So you think
And I mean, I also think that, I'm going to keep harping on data communication because I think that you can argue that right now, user devices like phones are basically data sinks. Data flows towards the phone. We're thinking that will change in the next 10 years, that the terminals will become sources of data. And that means the uplink is going to become more important. And sensing is a part of the uplink too. Can you sense the reflectors on the uplink channel? Can you understand how they're going to evolve? Can you do grant-free multiple access? Can you support a large number of users, only some of whom are active at any time? So these are, I think, use cases that might resonate better with mobile network operators. They don't have to imagine a market that is very far from appearing.
Great. So you all are popular. You're stoking a lot of conversation. We are getting a lot of questions in the chat.
Good.
And yeah, this is great. Anton, I'm going to go back to when you were talking about use cases, because you did mention environmental, and coincidentally, somebody had also emailed about that, about the ability to sense. I mean, what are you able to sense? Are you able to sense particulates? Or are you able to sense, what are the different types of things? Help
I,
explain on this for us.
I,
Only
I'm,
initials are DR.
yeah, I think, I mean, we have been focusing on more defense related areas and drone detection and drone swarm detection. It's a huge concern, as people know. I know we're not talking about the environmental monitoring yet, but this is a problem that governments around the world do not know how to solve. There is no solution right now for the detection of large scale drone swarms that, while not a threat yet in the US, are a very real and daily threat, not just in the Ukrainian war, but also on with at European borders. I mean, we've seen it with Poland. So that I think is driving a lot of the discussion from global governments, Western governments in our case. In terms of environmental monitoring, I mean, this is where AI can really come in to help. So, usually when you talk about radar, you're talking about detection of targets of a particular cross-sectional area. Well, that doesn't really work when you talk about a particulate. But there are characteristics of every kind of target that may be well suited to AI detection and AI target detection. So, I mean, Rob may likely be able to see. He's been working on radar a lot longer than I have. I joke that a lot of us communications engineers are now trying to be radar engineers. The world used to be fairly separate, radar engineering and communications engineering, communication theory, and they really are colliding right now. But I think having a waveform that is well suited to AI-based training, meaning it has a certain amount of stability in terms of channel and propagation, enables more sophisticated use cases. I do not know if or how much any work has been done on these complex detection use cases like real environmental monitoring. But I think and almost anything is possible if you can characterize a signature of the target that you're trying to detect. Rob?
Yeah, let me just pick up on that because as a fun fact, I mean, when you have a fire, right, like a big wildfire, there's a fire front. And in that fire front are lots and lots of insects. And if you go into a certain scientific literature, there's all sorts of papers about the radar cross-section of mosquitoes and things like that. And so you could actually track fronts by tracking the things in the fronts. So that's an interesting environmental use case.
That's interesting. That's great. So Anton, you mentioned um, waveforms. We have about 15 minutes left, and I'd really like to focus on waveforms because we have been in the same world for 4G and 5G. So is 6G the time? Do we really, in order to kind of take the next step, is it moving to an OTFS waveform? What are the benefits of making that move?
Okay, well now we get into my personal biases. Well, Cohere is known for this waveform OTFS and more recently ZAC OTFS, which is the fundamental variant. ZAC just means it's a type of transform, much like an FFT. It's a transform that transforms from the delay Doppler or sensing domain to the time domain. So 6G is looking at new waveforms. 6G within the 3GPP, they have also decided that the baseline, this is no surprise at all, this was expected. The baseline is OFDM. The real question is to what extent are the influencers and decision makers within 3GPP, the operators and others, willing to look at step functions, as I put it, in capabilities and performance. At the pure waveform level, it's pretty challenging, even though there are new, let's call them use cases, but they're really about new channels. I mean, FR3 is a new band. Most generations come with new distinct bands. In 5G, it was millimeter wave. And that continues. And in 6G, it's FR3, which is the band between about 7 and 24 gigahertz, I think. And there's a lot more spectrum that's available there. Those high frequencies come with more complex channels, especially if they're overlaid with existing macro base stations. So you have large Doppler offsets and large delay offsets. And there is work ongoing to continue to evaluate waveforms, although that is not going to go on for a whole lot longer because decisions have to be made by middle of next year. ISAC brings, as I said, a new paradigm. And the beauty of ZAC OTFS is it uniquely carries information in the radar domain, in the delayed Doppler sensing domain. So in many senses, it's an ideal ISAC waveform. It can carry data with high performance in complex channels. In simple channels, it just reverts to the same performance as OFDM. OFDM does a fantastic job in relatively straightforward channels. When you have reasonable Doppler, reasonable delay spread, the overhead is fairly minimal. But when you come to more complex channels and you come to more interesting use cases like integrated sensing, it is truly an integrated sensing waveform. And and so I think there is a lot of interest there around this waveform for those types of applications. We call the fundamental time domain view of this waveform the pulsone. It's a combination of a pulse and a tone. That is really at its core. That's what OTF is. It's a combination of a pulse and a tone, and it's invariant to delay and Doppler, which are the fundamental characteristics of the wireless channel. So, we'll see. We're in the process of building a ISAC base station, a flexible ISAC base station that'll support OFDM and OTFS and variants in between. One of the keys to 6G that enables coexistence with 5G is something called MRSS, multi-rat spectrum sharing. That just allows the scheduler to schedule both 5G and 6G and prior Gs within the same time frequency boundary. But it also allows you to schedule other waveforms, and OTFS can be scheduled in exactly the same way. So there's no change to the upper layers. It makes for a very simple transition. It doesn't mean that the receiver is the same, but if the market is there and if national security interests driving mission first requirements in terms of performance and drone detection and things that are critical to national security and public safety, I think the opportunity is there for changes and adoption, especially as we make the spec more flexible when it comes to scheduling.
That's great. So standardization. So how are the standardization efforts balancing between the cutting edge like ISAC and NTN while maintaining global interoperability?
Is that the question?
Yeah.
I don't understand.
Yeah. How do you see the standardization efforts impacting moving in this direction?
Well, they impact everything. I mean, NTN's a different story. Actually, part of the discussion at Milcom is around the integration. It's sort of these heterogeneous networks, not just for data, but for sensing. Can you use satellites, for example, to sense threats? And the answer is yes, but to what extent, we don't really know. There isn't as much work going on there. So NTN will continue to evolve. I mean, NTN is not new. It came out in release 17. There are new capabilities. There's continuous, I would say it's more evolutionary than revolutionary. There continues to be work to improve the efficiency of the NTN networks. Remember when you've got a huge beam that might be 50 kilometers across, and another one is coming and you have to hand off to it, you have a massive number of handovers. So that's not something that 3GPP has done or needs to do for terrestrial. So these have already been addressed in some of the prior releases, release 18, for example, release 19. To improve the efficiencies, but more fundamental changes for NTN would include things like multi-satellite connectivity. There's very little you can do when it comes to satellites to improve the link margin. You've got a set reflector size on the satellite. You've got fixed transmission power on the satellite. You've got fixed transmission power on the UE, and you've got a certain distance, either that the GEO or the LEO satellite is. The LEO satellite distance will change, obviously, as it goes from a low elevation to overhead. So the only way to improve things in this very challenging environment is to connect to multiple satellites. And that is difficult to do when it comes to pre-correcting and post-correcting for things like Doppler. Another area where a more advanced waveform that supports high Doppler offsets could do significantly better. But I think those are some of the interesting things around NTN. Not sure if 6G is. It doesn't look like they're planning on looking at it for release 20. That may change, but certainly, I mean, these releases, they don't end at one release for 6G. There's multiple releases that ultimately result in 6G Advanced or 6G Advanced Pro and so on.
That's great. And Dr. Calderbank, there's a question for you in the chat, but I want to give you an opportunity to comment. And also, I just want to make a comment that this all sounds very much like the Golden Dome that's being discussed. Do you see applications?
Well, It's actually one of the things I wanted to say about NTN was that when people are being altruistic, they talk about bringing communication to the underserved. I think that these NTN platforms, they have to do something positive for urban, something positive for suburban, and in order to make the business case, you probably need some kind of sensing functionality because the underserved by themselves are not going to make the business case.
Right.
Yeah, it is very challenging. I mean, there's a huge difference between, I don't know what the latest numbers are for ARPUs in the US. Probably $50 or higher, certainly much lower in Europe. But in Africa, at least I recall from my time at Viasat, when we were looking at bringing connectivity to ultra-rural areas, they were $2 to $4 a month. So how do you make and satellite by its nature, with limited spectrum, the cost per megabit per second is typically orders of magnitude higher than what can be done in terrestrial. So I think there's a misperception that Starlink and other solutions are going to somehow compete in urban areas. I think they can compete with fixed wireless because the cost of bringing services once the satellites are up is very low, effectively free. It's just the fixed terminals. But in terms of cost per megabit per second, uh, competing with MNO networks, that I don't see that happening at all. And I think that from a direct-to-device standpoint, which is where most of the excitement is around that these days, I really believe it'll become a kind of a baseline requirement. And that doesn't mean that the business case is there, but it does mean that consumers will expect to have it as part of their services. That if they're out of coverage, if there's a black spot that's somewhere in a city, that's the value to urban. If they're just concerned about their kids and they're willing to pay a few dollars a month for an insurance purposes, that will bring the value.
Very good. All right, Dr. Calderbank, there is a follow-up question from some of your earlier comments. On Dr. Calderbank's point about explaining the benefits to MNOs, should the emphasis be more on revenue uplift than operational efficiency and savings?
Oh, so you're asking whether it's revenue or whether it's operations?
Yeah, so when you're explaining to the benefits to MNOs about upgrading to 6G, should the emphasis be more on revenue uplift, operational efficiency and savings?
So what I would say is that in the information economy, there are two keys to success. Key number one is being bigger than your competitor. Key number two is driving any efficiency out of your operations chain. So if you're able to make more effective use of the bandwidth you have, that speaks to the second. It's very hard to imagine. It's difficult for MNOs to imagine new revenue just appearing. They can't tell their shareholders that's going to happen. They can't. It's much easier to plan efficiencies.
Yeah, the thing is that the efficiencies came in 5G, but the revenue didn't come commensurately with expectations. And so the result of that is there is a huge pressure in 6G for 6G to not require capital infrastructure expenses and deployments, which is why there's such a big emphasis on software that you hear within the standards, and you hear it from especially European MNOs who deployed early and fast with 5G, and so they're looking specifically for software upgrades, and that brings about the whole bigger question: what is 5G, what is 6G, what is 7G, if not for a step function in network capabilities? If it's just a software upgrade of new features, well, why not? Why have Gs at all? Why not just continue this evolution? Phase one, phase two, 5G Advanced, 5G Advanced Pro. I've heard even some operators talk about this. We should be seeking. I mean, this is a bigger question, but we should be seeking these step functions and changes that require a change in Gs. And if we can't, then why are we deploying new Gs every 10 years? These are bigger questions and unlikely to change anything, but they should be asked. And some operators are asking them, why are we deploying every 10 years? Well, that's just the way the machinery of 3GPP and the telecom wireless cellular world works. Whether we want to or not, the Gs are coming every 10 years. So we got to figure out what goes in there. But it's running into this barrier where operators don't necessarily want to spend money on new infrastructure.
Yeah.
So
And
again,
it's like Anton's saying, I mean, it's super hard to get new innovation into public networks. It's perhaps easier to get them into private networks, like a defense network. And maybe we should be thinking about a way of proving things out in private networks and the ones that look positive, moving them into the public domain.
yeah, I mean, I'm very passionate about the open interfaces thing because as a startup, and as I see with our many academic friends, the challenge is the pace of innovation. I'm not saying there isn't innovation in 3GPP. Of course there is. There are phenomenal things happening, but you're stuck with certain types of innovation, software-based and so on. If the interfaces between layer one, layer two, layer three, as they are between, by the way, the core network and layer three, where you can use the 5G core for Wi-Fi or other types of networking through interfaces that have been defined in 3GPP, for example, the non-3GPP interworking function. If we had that at lower layers, it would allow innovation to proceed at its own pace. That doesn't mean that the costs would be there to support semiconductors, but it would, but it would allow innovation to happen and for markets to prove if those innovations are worthwhile. And then the markets would demand that costs be driven down. And the semiconductor companies, it would make sense for them to integrate those capabilities into their chips. But right now, we don't even have that capability. You have to take apart a stack and you have to do something very proprietary, very custom in order to make any changes.
Good. Well, gentlemen, we have 3 minutes left, so I'm going to do a fast round through some of the questions that we've received in the chat, and I want to give you 30 seconds each of closing. So, okay, so keep your answers tight so we can get through as many of these as possible. All right. Will 6G allow Will 6G allow user-to-user communications without infrastructure?
I mean, that was defined in 5G, but I would say effectively it failed. I mean, the semiconductor companies had solutions, but they didn't productize them. I know defense was looking very specifically for this use case, and it was not available from a commercial standpoint, so they were unable to deploy it. There is still a lot of interest. I don't know. It really is a question of does it make sense to the MNOs and therefore to the semiconductor vendors to integrate these capabilities because it will cost money to develop productized solutions. So I think the jury's out on that one.
Okay.
Nothing to add.
Okay. Will 6G support network slicing based on intent of sense?
I'll just hand that to Rob. I don't know.
I'm paying a
I like the
price for being.
question. I like the
What?
question. I don't know how to answer it.
Yeah,
Oh,
I don't really know
gotta
the
start with
answer either,
some.
but network slicing is a big thing.
Yeah, for sure. All right. Does millimeter wave have a life in fixed wireless and private networks?
I would say, from what I've seen, absolutely. I mean, some of these things just take longer to evolve. I was at an event maybe 6 months ago, and one of the big operators, well, actually, it was T-Mobile. They're pretty public about this. They're putting a lot of effort into fixed wireless, and they even are deploying millimeter wave now. This was done before, of course. It was driven by Verizon, but sometimes it just takes longer for either costs to come down or architectures that make operational sense to be deployed and also for the hype to be dispelled. It's not really about getting millimeter wave into your homes. So or necessarily for getting millimeter wave to cars, even though those things were proven to some extent. So I think, yeah, the millimeter wave has a continued life in fixed wireless.
Yep,
Yeah.
I agree.
I think it's a happy accident. I mean, millimeter wave was not conceived as a fixed wireless solution.
Yeah.
The fact that it has enabled a fixed wireless solution is one of the small number of positives the MNOs take away from millimeter wave.
Fantastic. Well, gentlemen, we are exactly on time. So we
Okay.
will have to leave it here. We had many, many questions in the chat. I'm sorry if we weren't able to get to them all. We appreciate Dr. Monk and Dr. Calderbank for joining today, and thank you for the 6G Forum for having us.
All right. Thank you for inviting us.
Thanks, Dan.
Bye-bye.